Okay. Students, with respect to speed time distance, there are three concepts to be remembered. Concept number one, when your distance is equal to constant. When your distance is equal to constant, distance is nothing but speed into time. Therefore, speed into time is equal to constant, or in other words, speed is inversely proportional to time. Or in other words, speed 1 by speed 2 will be equal to time 2 divided by time 1. Or in other words, to cover a same distance, let's say distance is equal to 100 kilometers. To cover the same distance, if you are going at a speed of 100 kilometers per hour and you are going at a speed of 50 kilometers per hour, if you take two cases, what is the ratio here? Speed ratio is 2:1. The time taken ratio will be 1:2. That is the concept. When distance is equal to constant, the speed ratio, you inverse it, what you will get is time ratio. This is concept number one. This is the only place where you will have an inverse relation. In all the other two cases, you will have a direct proportionality. For example, concept number two. When time is equal to constant. When time is equal to constant, distance is directly proportional to speed. You are given only 5 hours. So if you want to cover more distance, you have to go at a higher speed. If you want to cover less distance, you have to go at a lower speed. So distance 1 by distance 2 equals to speed 1 by speed 2. So you are given 5 hours to travel. If you are going at a speed of 10 kilometers per hour and if you are going at a speed of 20 kilometers per hour, respectively you will be covering distances of 50 kilometers and 100 kilometers respectively. So here the speed is in the ratio of 1:2 and correspondingly the distance covered also will be in the ratio of 1:2. This is concept number 2. Concept number 3 is also similar when speed is equal to constant. When speed equals to constant, once again distance and time are directly proportional to each other. So when distance 1 by distance 2 will be equal to time 1 by time 2. Let's say you are going at a speed of constant speed of 50 kilometers per hour. If you travel for 1 hour, you will cover 50 kilometers distance. If you travel for 10 hours, you will cover 500 kilometers distance. So here also the ratio is 1:10. Here also the ratio is 1:10. That is, when the speed is constant, whatever is the time ratio, the same ratio you will be having your distance also. Or whatever is the distance ratio, that is the same ratio you will have your time. So these are three basic concepts in speed time distance, right? The beauty of this question number 26 is all these three concepts are actually occurring in this one particular question itself. Let's go ahead and see how all these three concepts are occurring in a single question. First, what is the scenario that we have? A train X starts from Agra at 5 p.m. and reaches Delhi at 6 p.m. So let's call this as Agra and let's call this as Delhi. A train X starts from Agra at 5 p.m. So X is starting here at 5 p.m. and it is reaching here at 6 p.m. And another train Y starts from Delhi at 5 p.m. and reaches Agra at 10 p.m. After how many minutes from the starting do the trains meet? We'll go step by step. Firstly, let's go ahead and try to identify speed ratio of these two particular trains. To understand the speed ratio, we are going to use concept number 1. X has covered the entire distance in 1 hour. So the distance is entire distance. How much distance has the train X covered? The entire distance D. How much distance has the train Y covered? The entire distance D. So the distance covered by the first train is equal to the distance covered by the second train. So the distance is equal to constant. So what can I say about speed and time? Speed and time are inversely proportional to each other. So time taken for first train x is equal to 1 hour for the entire distance. The same distance, time taken for the second train is 5 hours. Or in other words, times of the x train and y train are in the ratio of 1:5. So using concept number 1, can I now go ahead and say that their speed ratios will be 5:1? Yes, I can do this because I have established that the distance parameter is constant for both the trains. One train is traveling from Agra to Delhi, another train is traveling from Delhi to Agra. So the distance is constant. So using distance is constant, that is concept number 1, we have established their speed ratio. This is first part of the problem. Going to the second part of the problem, both the trains are starting at 5 pm. X train is starting at 5 pm here, Y train is starting at 5 pm here, right? Their starting time is same, and let's assume that the trains are coming and meeting somewhere in between. Meeting time is a common time for both the trains because meeting is an event which is happening at the same time for x as well as y because it is xy meeting time, right? So when is train x and train y meeting? It could be some time, whatever the time, 5:15, 5:20, 5:30, 5:40, 5:50, whatever the time. That time is same for x and that time is same for y. That time is what we will call as meeting time of x and y. So the starting time of x is same, the starting time of y is same, 5 pm, 5 pm. Meeting time is same. So between these two time instances, the time duration of x, time duration of x and time duration of y in the second part is same. So I am not considering the entire journey from Agra to Delhi. If I consider the entire journey from Agra to Delhi, this is this part 1, time won't be same. The time is actually 1 hour 5 hours. Time is different. Only distance will be same. I am not considering that part. I am considering the part where these two trains start at 5 pm and come and meet. For this section of the journey, time component of both the trains are same. So when time of x is equal to time of y, what do we know? Please refer to concept number 2. Concept number 2 says distance ratio will be equal to speed ratio. So what is the speed ratio? Speed of x is to speed of y equals to 5:1. So it is the same ratio that they would have covered their distances as well. So distance traveled by x and distance traveled by y will also be in 5:1 ratio. So if you take the entire distance between Agra and Delhi and split it into 6 parts, 1, 2, 3, 4, 5, 6, the left side train, x train, would have covered 5 units, whereas the right side train would have covered 1 unit, and they would have met at a distance of 5 units from left side or 1 unit from right side. So this is second part of the problem that we have concluded using concept 2. Now let's go to the concept number 3. How do I get to know what time this particular meeting has happened? So right now I'm going to focus only on the train x. So I'm only focusing on train x. So the train x is going at some speed, whatever speed. So the train x, it is traveling from here, some meeting point is happening and it is continuing to travel here. So throughout this journey, can I go ahead and say the speed is constant? I'm only focusing on train x. So throughout this journey, I'm completely forgetting about train y. Throughout this journey, I'm taking that the speed of x is constant. So speed of x is equal to constant throughout the journey. So what I can tell here is, refer to concept number 3, the distance ratio will be equal to the time ratio. So what is the distance that the train has traveled for the first part and second part? First part is 5 units. Second part is 1 unit. So accordingly, the time component also would be split in 5 units is to 1 unit. So the total time taken is 60 minutes or 1 hour. 5 o'clock to 6 o'clock, right? So it is 1 hour. So if I split into 5 into 1, so here it would have taken 50 minutes and here it would have taken 10 minutes. So this one problem looks like a very simple problem, but all these three concepts are beautifully covered in this one problem itself. Of course, the problem can be solved faster, but I wanted to emphasize all these three concepts. So which is why I took this approach to explain all these three concepts. I hope it was clear enough.